Hi guys, hope you all are doing good. I welcome you to this amazing channel of Brilliant Kratha. In today's session we are going to do quadratic equation. This is the third lecture in our JEE Maths Crash Course. Coming to the importance of this particular chapter, quadratic equations in our JEE Maths. In spite talking the importance of this particular chapter, this chapter can be considered as the basic fundamental chapter where we come across each and every concept of quadratic equations in all the remaining chapters. Like we come across trigonometry or calculus, everywhere we come across the basic concepts which are from quadratic equations. So just instead of considering this particular topic as one single topic, let's make sure that the concepts of this particular chapter are going to be useful for all the chapters in grade 11 as well as grade 12. So that's the reason from beginning I used to say basic maths, number 2 sequence series, number 3 quadratic equations, number 4 trigonometry. These 4 are the basic fundamenta of all our grade 11 and 12 topics. Clear, friends? And we have very good number of concepts from quadratic equations, and like the graphical analysis always leads us to the better and best approach. So guys, without any delay, let's start our today's session. The flow of the content in today's session is going to be like, we'll be starting like introduction of quadratic equation, identity, relation between roots and coefficients, nature of roots, common roots of two quadratic equations, maximum and minimum values, location of roots, theory of equation, and transformation of roots, we say. Okay. Yeah, friends, like from grade 10th itself, we have seen many times the definition of quadratic expression, quadratic equation. Any, like a polynomial of degree 2 is said to be a quadratic polynomial, where like any general form of quadratic equation is always going to be of the form ax squared plus bx plus c, where a comma b comma c are three real numbers and the coefficient of x squared shouldn't be 0. See, the coefficient of x squared shouldn't be 0 because if the coefficient of x squared is going to be 0, then this particular equation can't be called as a quadratic equation. We say it as just a general linear equation, we say. So that is what. Next, roots and solution. I come across many students will be having a bit confusion between these two words called roots and solutions. I'm just going to clear everything in this particular now. See, just do understand. First, before we start the definition of roots and solution, one thing, friends, any equation of degree n, just remember this, any equation of degree n will be having n roots. That's it by default. If it is quadratic equation, 2 roots, cubic 3 roots, biquadratic 4 roots, 10th degree equation 10 roots, and I'm not saying real roots. So just imagine roots. Any equation of degree n will be having n roots. Forget about their real imaginary, but in total it will be having n roots. Now let's try to understand roots and solution for a simple quadratic equation. Just see, friends, like now I have like I have taken x square minus 3x plus 2 is equals to 0. Okay? X square plus 2x plus 1 equals to 0. I can just write this as x minus 1 into x minus 2. That becomes x is equals to 1 and x is equals to 2. Here if I say x plus 1 equals to 0, I just say x is equals to minus 1. Whereas some other, if I take x square plus x plus 1 equals to 0, by using as the discriminant of this is less than 0, I can just by using our quadratic formula minus b plus or minus root b square minus 4ac minus b plus or minus root b square minus 4ac whole divided by 2. So that becomes minus 1 plus or minus I root 3 whole divided by 2. Friends, in all the three cases, since it is a quadratic equation, we are having 2 roots. That's it. Here we are having 2 distinct roots, 2 distinct real roots. Here we are having repeated roots, but 2 roots we have, both the roots are minus 1 comma minus 1. Here we are having 2 roots, but these 2 roots are imaginary. These 2 roots are imaginary. Now let's try to understand the word solution. Always, my dear friends, solution is nothing but solution of a particular equation is nothing but number of distinct real roots. Number of distinct real roots. Here 2 solutions. Here though we have 2 roots, but these two are not distinct. Okay, so hence one solution we have here, no solution. Guys, hope it is clear. Solution is something number of distinct real roots. Very important, friends, very important. I hope everyone have understood this particular thing. Next, starting with identity. Another important definition that we have in quadratic equation is identity. See, identity is something, a statement which is true for all the values of the given variable. Such statements are called as identities. Now, how do we relate this identity or quadratic equation? Just now we have discussed a quadratic equation ax square plus bx plus c equals to 0 will be having two roots. That's it. Two roots. Now, if I say this quadratic equation is going to have 3 roots or 4 roots or 5 roots, not possible now, but it will be possible at one particular case, that is, and the case is equals to a equals to b equals to c equals to 0. So that is ax square plus bx plus c equals to 0 is said to be an identity if a equals to b equals to c equals to 0. All these coefficients a, b, c, when they are equals to 0, then that will be having n number of roots, any number of roots like 3 roots, 4 roots. So any equation of degree n, if it is having greater than n roots, then such equation is said to be an identity. For an identity, all the coefficients we are supposed to equate them to 0. Guys, clear? So that becomes ax square plus bx plus the quadratic equation ax square plus bx plus c equals to 0 is said to be an identity if all the 3 coefficients are equals to 0. Relation between roots and coefficients. As simple as it is in grade 10. Suppose we have an equation ax square plus bx plus c is equals to 0. Then we say if alpha comma beta are the roots of these equation, alpha comma beta are the 2 roots of this particular equation. Friends, sum of the roots minus b by a, product of the roots c by a. That's it. Sum of the roots minus b by a, product of the roots c by a. So this is how the relationship between roots and coefficients of a quadratic equation ax square plus bx plus c equals to 0, and the roots can be found out by using the quadratic formula minus b plus or minus root b square minus 4ac whole divided by 2a, This particular quadratic equation roots can be found easily by using the formula x is equals to minus b plus minus root b square minus 4ac whole divided by 2a. And one more thing, friends, like if roots are known, if alpha comma beta are the roots of a quadratic equation, then the equation of such quadratic is going to be x square minus x into alpha plus alpha beta equals to 0. If alpha comma beta are the roots, then we can get, by using this particular formula, we can get the corresponding equation of the quadratic equation. Yeah, that is what quadratic equation whose roots are alpha and beta is going to be x square minus x times alpha plus alpha beta equals to 0. Nature of the roots. Consider the quadratic equation ax square plus bx plus c. Friends, this particular expression d is equal b square minus 4ac is said to be discriminant of the quadratic equation. Discriminant because it is what, like this particular factor is going to determine the roots, determine the nature of the roots. So that's the reason why we say discriminant. In general, we denote it with capital D. Now, guys, basic things. First, try to understand. Number 1. If the discriminant of a quadratic equation is going to be 0, in general we know now, like x is equals to minus b plus minus root b square minus 4ac whole divided by 2a. So if this value is going to be 0, then we get x is equals to minus b by 2a, which implies x plus b by 2a is equals to 0. But this becomes linear, no? So we will be squaring it both sides so that the equation will be of the quadratic form. So when friends, when d equals to 0, we say the particular quadratic expression can be expressed as the square of a linear expression. When d equals to 0, quadratic expression is expressed as square of a linear expression. Square of a linear expression. They will be giving you in problems, they will be analyzing you in this way, like for what value of n or for what value of so and so, this particular quadratic expression can be expressed as a square of linear. That means the discriminant is going to be 0 in that case. Understood? Number 2, we can even say repeated roots, same roots, repeated roots, or we can even say roots are real and equal. So in any one of these three, they can give you, in this case, then the result as is going to be discriminant equals to 0. Now second case, let's try to understand d greater than 0. Whenever they say d greater than 0, the roots are real and distinct. This is very primary. Okay, apart from that, there are two most important things that we are supposed to know is, friends, please make a note of this. When d greater than 0, roots are real and distinct. But how they are? If you just go in depth of the characteristics of the roots, then case 1, d is a perfect square. D is a perfect square. If d is a perfect square and this is very important, all the coefficients A, B, C are rational. Friends, if d is a perfect square and all the coefficients are rational, then roots are rational. Very important. This particular thing, majority of the students will be neglecting this. No, this is what the heart of this particular statement. Discriminant is a perfect square and ABC belongs to rational numbers, then roots are going to be rational. Number two, if d is a non-perfect square and all the coefficients are rational numbers, then roots are irrational and in pair. Pair means, like, if one root alpha is going to be like a plus root b, then beta is going to be a minus root b. In pairs, in conjugates. Where again, in this also, this particular statement is going to be very important. When A, B, C are rational numbers and discriminant is a non-perfect square number, we say roots are irrational and in pair. And coming to the third case, friends, case 3, discriminant equals to 0, greater than 0, and discriminant less than 0. We say roots are imaginary. In this also, there is one particular important thing that we can say is, friends, if discriminant less than 0 and a comma b comma c are real numbers, please make sure all the coefficients are real, then only we can say roots are imaginary and in pair. This is very important. Roots will be imaginary. See, discriminant less than 0, roots are imaginary, no doubt, but they will be in pair only if all the coefficients are real numbers. Then only the roots will be in pair. Hope everyone understood this, guys. Please make sure you are going to take a screenshot of this, or else Please note it down. Very important, because the problems, the approach in problems, we are going to go with these three things only. Clear? Next, first question in today's session. For what values of k the expression 4 minus k times x square plus 2 times of k plus 2 into x plus 8 times 8k plus 1 will be a perfect square? Friends, just now we have seen perfect square. A quadratic expression is going to be a perfect square. Means, what do you mean by that? Perfect square means the discriminant is equals to 0. That's it. That is the primary thing. Discriminant of this quadratic expression is going to be 0. So discriminant, equate the discriminant to 0. That means b square minus 4ac. B square is equals to 4ac, which implies 4 times k plus 2 whole square is equals to 4 times 4 minus k into 8k plus 1. 4 gets cancelled. K plus 2 whole square is k square plus 4k is equals to 4 8s 32k plus 4 minus 8k square minus k. Now everything is going to be like k square plus 8k square, 9k square, 32 minus 1 will be 31, 4 minus 31 minus 27k, 4 gets cancelled is equals to 0. We can just take 9 out. So k square minus 3k is equals to 0. K can be either k of k minus 3. K can be either 0 or k can be either 3. So this is how we are going to get the values of this particular thing. Clear, friends? For these two values of k, this expression, see, the fundamental thing of this particular problem is simple. What is the fundamental thing? Discriminant of this is going to be 0. Clear? That's it. Next, show that the expression will be a perfect square if a equals to b equals to c. Again, basic maths. The coefficients looks like something we can relate with algebraic identities. Yeah. And it is square of something. Means, what do you mean by that, friends? The discriminant of this is going to be equals to 0. Equate the discriminant to 0, friends. So discriminant of this, that is b square is equals to 4ac. 4 times of a plus b plus c whole square is equals to 4ac. 4 into 1 into, so 4 3s are 12 times bc plus ca plus ab. 4 1s, 4 3s. So that becomes a square plus b square plus c square can be written as a square plus b square plus c square plus 2ab plus 2bc plus 2ca is equals to 3ab plus 3bc plus 3ca is equals to 0. Sorry. Now that becomes a square plus b square plus c square minus ab minus bc minus ca is equals to 0. Friends, we all know it now. Like this can be written as half of a minus b whole square plus b minus c whole square plus c minus a whole square is equals to 0. Sum of the squares of three real numbers. Sum of the squares of three real numbers will be 0 if all the three are 0. That means a minus b 0, b minus c 0, c minus c 0. A equals to b equals to c we get. See, that simple it is. A quadratic expression can be expressed as the square of one linear expression if the discriminant of that particular quadratic expression is going to be equals to 0. Next question. If one root of this equation is root 3 plus 2, then other root of the equation. See, friends, very like majority of the students by this time itself they will be taking that root 3 plus 2 is one root, 2 minus root 3 is going to be another root. Roots are, they feel like they are conjugate in pair, but that happens only when all the three coefficients are rational numbers. All the three coefficients are rational numbers. Never make that mistake again. Never make the mistake again, because here the coefficient of x is root 3, not a rational number. Discriminant greater than 0 and all the coefficients are rational numbers, then only we say roots will be irrational, that too in pair. Clear? So now let the other root be alpha. Okay, Now we go with sum of the roots. Alpha plus 2 plus root 3 is equals to minus b by a, which is equals to root 3. Root 3 gets cancelled. Alpha is equals to minus 2. That's it. So this is how we will be eliminating. Make sure you are not going with wrong approach. Good friends. Next thing, if alpha and beta are very important, like alpha, beta are the roots of this particular equation. Clear? Now they are asking us to get this. See friends, like first one and second one can be done easily. How can be done easily? So if they are asking like 7 plus, see, just check this, I am asking, check this. 7 plus alpha into 7 minus beta can be done as 7 square, 7 into 7, 49. 7 into minus beta, 7 into minus beta, we just take plus beta for easier calculations. I will tell you, even minus beta occurs, what happens? Plus 7 times alpha plus beta plus alpha beta. See friends, alpha plus beta you know, alpha beta you know. Clear? Alpha plus beta you know, alpha beta you know. You can get it because sum of the roots alpha plus beta is equals to minus b by a, and alpha into beta is equals to plus 1. But in case like if it is minus here, what happens? Then 49 plus 7 times of alpha minus beta minus alpha beta. Friends, when you know alpha plus beta and alpha beta, can't you get alpha minus beta? We can, because a minus b whole square will be equals to a plus b whole square minus 4ab. By using that, get the value of alpha minus beta and just substitute it. Same way we can do it here. Bit there are like these two can be like they are finding like bit complex things we feel like, but whenever they give you such expressions, friends, the first important thing, just rather going with normal LCM like alpha square into b plus 1, majority of 95% of the students go with directly LCM and then multiplying. That makes a very complex thing. Instead that, understand, do we have any correlation with respect to the given part? Any correlation of that option with the given part. Just common sense, like if alpha and beta are the roots of this equation, then we can say alpha square plus 3 alpha plus 1 equals to 0, because we can substitute alpha in place of x. In the same way, beta square plus 3 beta plus 1 is going to be 0. From there, friends, like what is 3 alpha plus 1? Which is equals to minus alpha square, and 3 beta plus 1 is going to be minus beta square. See, alpha square by 3 alpha plus 1 is going to be minus alpha square, and beta square by beta plus 1, 3 beta plus 1 it is. 3 beta plus 1 is again beta square by minus beta square. So just finally minus 1 plus minus 1, directly we got it. Clear? Is that clear, friends? Is that clear? That much simple it is, friends. Very simple. There is nothing in it like, okay. Is that all clear? Next, in the same way, this is something all as like we have got this answer. Like in the same way, alpha by 1 plus alpha, alpha by 1 plus alpha whole square. That is nothing but alpha square by 1 plus beta square plus 2 beta. 1 plus beta square plus 2 beta. See, just a common sense, like already we have beta square plus this 3 beta can be written as 2 beta plus 1 plus beta is equals to 0. So beta square plus 2 beta plus 1 can be written as minus beta here. Basic common sense, basic thing. So that's how we are going to get the required things. Always, like whenever they are in complex form, just not instead going with LCM, that takes too much time. See, because time is one of the most important constraint in our objective thing. Make sure that you do have any correlation. In spite, if you are not going to have any correlation, then no other option we have. But majority of the times no one asks us to go with putting major time in calculation. So always make sure that you are identifying some correlation with the given part and the required thing. Good. Next, let one root of the equation is square of the other root. then and m belongs to capital R, then they are asking us to get the value of EL. Have you all understood, friends? This question was asked in the year 2019 JEE. See friends, like again, like very simple. If one root is alpha, the other root is alpha square, because they said one root of the equation is going to be square of the other root. Now, if you just see friends, if you just see, what is the sum? Sum of the roots minus L. Product of the roots alpha into alpha square, which is equals to alpha cube, which is equals to m. From here, can we say m? So we have alpha plus alpha square is equals to minus L, and alpha into alpha square is equals to m. Now from here, alpha is equals to m to the power 1 by 3 I get. Alpha is equals to m to the power 1 by 3. Let me substitute that here, friends. So m power 1 by 3 plus m to the power 1 by 3 whole square is equals to minus L. Here m is a real number. M is a real number. So definitely m power 1 by 3 will also be a real number. Let me take that as some t. Clear? M power 1 by 3 as some t. Let t be also a real number. Now that becomes t square plus t square plus t plus L is equals to 0. This is a quadratic equation in t, where t is real. If t is real, discriminant of this equation is going to be real. That means what is the discriminant? B square. 1 square is always greater than or equals to 4L. So 1 greater than or equals to 4L. L 4L less than or equals to 1, that implies L is less than or equals to 1 by 4. Therefore, L belongs to minus infinity to 1 by 4 closed. Yeah, we are done, but just see, look at this union 1. The purpose that they have given union 1 is, friends, very simple. They didn't mention like anything that x is going to be real or imaginary. X is going to be real or imaginary. If x is going to be real, this is what the things happen. But if x is not going to be real, that means even omega satisfies here. La? If alpha is equals to omega, then omega plus omega square is equals to minus 1. So if you are going to just compare these two, friends, if you are just going to compare these two, L will be equals to 1. Hence the correct option is going to be L belongs to open infinity, negative infinity to 1 by 4 closed union 1, because they didn't mention anything about alpha like roots of this particular equation, whether they can be real or else imaginary. Real, this solution. Imaginary, L has to be 1. Next, if alpha and beta are the roots of an equation, then the value of alpha power 8 plus beta power 8 is going to be very basic thing, friends, very basic thing. As we have alpha plus, see, in general we will be having alpha plus beta and alpha into beta value. Na? What is alpha plus beta value? Minus 5 to the power 1 by 4. Alpha into beta value 5 power 1 by 2, which is equals to root 5. Now by using these two only, see, alpha plus beta whole square, we already have alpha square plus beta square plus 2 alpha beta. Is this clear? What is alpha plus beta? Minus 5 whole power 1 by 4. Whole square is nothing but root 5 we get. Root 5 is equals to alpha square plus beta square plus 2 alpha beta, means plus 2 root 5. So finally we get alpha square plus beta square is equals to negative root 5. Friends, whenever they give you even powers of like this, even powers, the situation is like squaring them again till you get the required thing. Very simple thing. Even powers always do that. Odd powers, using alpha plus beta and alpha beta, somehow get the relation between alpha and beta by using our all. Now again squaring on both sides. Then what happens, friends? Alpha square plus beta square whole square in general will be alpha power 4 plus beta power 4 plus 2 times of alpha beta whole square. So that becomes alpha square plus beta square whole square, means 5 will be equals to alpha power 4 plus beta power 4 plus 2 times of alpha beta whole square. So 10 5 minus 10, hence alpha power 4 plus beta power 4 is going to be minus 5 now. Is this clear? Next, again squaring on both sides, then we get alpha power 4 plus beta power 4 whole square is equals to alpha power 8 plus beta power 8 plus 2 times of alpha beta whole to the power 4. Friends, just substitute here. 25 is equals to alpha power 8 plus beta power 8 plus 2 times of alpha into beta is root 5. Root 5 power 4 is 25. Root 5 power 4, like root 5 is 5 power 1 by 2 whole power 4. So 5 square it's going to be 25. Then from there, friends, alpha power 8 plus beta power 8 is going to be minus 25. So that's how we do get the value of that required thing. Clear everyone? Next, alpha and beta. Yes. For this particular problem, I would like to tell you one most important concept that we have here for such types of questions in quadratic equations. Very important. So before I solve this problem, I'll be giving you like this particular very important rule, and the rule is going to be Newton's formula. We say it as Newton's formula. My dear everyone, please make sure you copy it properly. Newton's formula. Sir, how do we understand Newton's formula? Just simple. For a quadratic equation, ax square plus bx plus c, alpha comma beta are the roots, and if they give you an expression, some pn is equals to either alpha power n plus beta power n or alpha power n minus beta power n. Friends, be clear with the thing. Whenever they give you such expression, pn is going to be like pn or en or tn, some xn, anything, a power alpha power n plus beta power n or alpha power n minus beta power n. In all these cases, if you know the expression, this, yes, just very simple, the decreasing order of the subscript of pn. That means like if you are going to start from like a pn plus b times of pn minus 1, friends, here pn then n minus 1 plus c times of pn minus 2 is equals to 0. When you write the last one, n minus 2 should be greater than 0, n should be greater than 2. You understood everyone? Have you all understood? It's not that it has to start from only n. If I start from n plus 1, like a pn plus 1 plus a times of like b times of pn decreasing consecutive plus c times of pn minus 1 will be again 0, then n will be greater than 1, greater than or equals to 1, no issues. Like even like n, if p naught means 1 plus 1 will be equals to 2, no? In that way, we starting from higher subscript with the coefficient of x, then consecutive in decreasing order. Very important, this Newton's formula, very important, my dear friends, very important. Now by using Newton's, see, if you know this Newton's formula, you have like all such problems based on this will be solved just less than 20-30 seconds itself. But if you are not aware of this, it takes minimum 3 to 4 minutes of our valuable time. Always stick to Newton's formula whenever you come across such scenarios. Okay, now just see, like, see, they have given alpha power n plus beta power n, but to apply Newton's formula, we have to get the quadratic equation. Quadratic equation is mandatory, okay, but for that they have given alpha plus beta and alpha beta, friends. So that's it, x square minus x minus 1 is equals to 0. This is what we are going to have quadratic equation, because when roots are given, x square minus x into alpha plus beta plus alpha beta equals to 0. Alpha plus beta we know, alpha into beta we know, just substituting that. Now what is the value of a? A is nothing but the coefficient of x square. B, a1, b minus 1, c negative 1. So now we need, like, starting from higher, n plus 1. So a times of p n plus 1. What is a, friends? Now let's substitute everything here, okay? A times, that is 1 times pn plus 1, I am just write it, plus b times, b is minus 1, pn plus c is again minus 1. Pn minus 1 is equals to 0. Clear? Now just see, Pn plus 1 value they have given as 29, minus Pn we don't know, minus Pn minus 1. Pn minus 1 is 11. So minus 11 is equals to 0. From there, what is Pn, friends? 18. That's it. Ho gaya, friends. See, how much time did it take to complete this one? Less than 30 seconds. Less than 30 seconds. Now they are asking us to get Pn square. Pn square. 18 square, which is equals to 324. That much simple it is, friends. Very simple. Whenever we come across such expression, always make sure you are identifying it and applying Newton's formula. My dear friends, very important. Very important this one. Like in the past 2 years itself, 3 years, 4 years itself, we have seen like at least one question in every paper of at least one question from quadratic equation, and that too majority of the times they have asked from Newton's formula itself. So always make sure you are clear with it. Very important concept. Next, alpha and beta. See, again this is a question like, see, an they have given, then the value of a10 minus 2a8 by 2a9. Higher one is a10 na, just like we know na, what is the coefficient of x square? 1 into a10 minus 6 into a9 minus 2 times of a8 is equals to 0. From here, a10 minus 2 times of a8 is equals to 6 times of a9. Just to substitute there. What is a10 minus 2a8? We have 6 times a9 by 3 times a9. a9 gets cancelled, 6 by 3, 2. Friends, this is a JEE question. We took just 10 seconds to solve this, just by using our Newton's formula. So my dear friends, I just remind you Newton's formula. Whenever you see like such expression, alpha power n minus beta power n or alpha power n plus beta power n, always stick to Newton's formula. That makes very simplifier. Another again Newton's formula, friends. For this, the sequence is very important. Like starting from, see, 854, no sequence. 854, again no sequence. 656, no. 654, that's it. See, coefficient of 5. So 5 times, like x square is 5. 5 times of s6 plus 6 times of s5 minus 2 times of s4 is equals to 0. That's it. This is nothing but option 4. How much time did we invest in it, friends? How much time did we invest in it? Nah? Clear? Next, alpha and beta are the roots of a so and so equation, and gamma and delta are the roots of these two equations. These are in geometric progression then. This was asked in the year JEE 2020. Analyzing any question from quadratic equation. Very simple analysis. See, we don't have much concepts in quadratic equations. Very simple concepts we have, and only that we are going to apply. Clear? See, friends, now alpha and beta are the roots of this particular expression. X square minus 3x plus p equals to 0. What are the roots of this? One is alpha and the other is beta. Next we have another equation, x square minus 6x plus q is equals to 0, and the roots of this are gamma and delta. Gamma and delta. Okay, these alpha, beta, gamma, delta are in geometric progression. Yesterday itself, in the previous session itself, we have seen sequence and series. See, let me take this as alpha, this as alpha into some r, common ratio, alpha into r square, into alpha into r cube. Do you all agree? Since they are in geometric progression, let r be the common ratio. So I have expressed everything in terms of r, alpha and r. Clear? Now see, what is sum of the roots in the first case? Alpha plus alpha times r is equals to 3. Sum of the roots in the second case? Alpha square, alpha r square plus alpha r cube is equals to 6. Alpha common, alpha of 1 plus r is equals to 3. Alpha r square common, of 1 plus r is going to be 6. Friends, just dividing these, then you get 1 by r square is equals to 1 by 2, which implies r square is equals to 2. Have you all understood till here, friends? Very simple, no? Now you see, let's take product of the roots thing. Product alpha into alpha square, that is alpha square into r is equals to p, and from here alpha square into r power 5 will be equals to q. Again divide, friends. 1 by r power 4 is equals to p by q. Already r square is, so p by q value is going to be 1 by 4. We got something. Now how we are going to relate this to get that particular required one? Okay, just do understand, my dear friends. 2q plus, we need to get 2q plus p whole divided by 2q minus p. Just divide q, both numerator and denominator. So this can be written as 2 plus p by q by 2 minus p by q. We got the value of 1 p by q. So 2 plus 1 by 4, 9 by 4 by 2 minus 1 by 4, 7 by 4. That's it, friends. 9 divided by 7. First option. Simple. Approach is going to be very simple, friends. See, have you understood this? Good. Next one. Alpha and beta are the roots of so and so. Then the value of alpha by 1 minus alpha square. Very simple, friends. There is nothing in it actually. There is nothing. It was asked in the year 2019 JEE mains. Now just see. Normal LCM, alpha into 1 minus beta square. So alpha minus alpha beta square plus beta into 1 minus alpha square. Beta minus beta times alpha square divided by 1 minus alpha square into 1 minus beta square. So numerator, I can just take alpha plus beta times minus alpha beta. If I take common from those two, I get alpha plus beta. Denominator, 1 minus of alpha square plus beta square plus alpha square beta square. So plus alpha square into beta square. You know already alpha plus beta, you know already alpha beta. Friends, do we have any term which is not going to get by using alpha plus beta and alpha beta? Such a simple question, such a very simple question. Clear? I'm just assigning you to complete this as homework. Chalo, friends. Next one. If alpha and beta are the roots of this particular equation, then the value of this. See, the moment you have seen this like power 3, power 5, majority of the students try to skip this particular problem. Whenever they give you something in complex, there might be some correlation with that part, with the given thing. That's it. Required and given will be, there will be some correlation between those two. Is that clear? Now see, the approach is going to be very simple. Just like LCM alpha power 3 into alpha power 5, we get alpha power 8, 1 by 8, like numerator is alpha plus here also numerator alpha plus beta whole divided by alpha into beta whole to the power 5 by 8 I can write. See, from here to here, how very one single step we got. In that one single step, we covered a majority of the part. Now we know alpha plus beta. Alpha plus beta is just 64 and alpha into beta is 256. हो गया ना? Alpha plus into is 64 divided by alpha into beta is 256. 256 is nothing but 2 to the power 8. So 2 power 4 divided by 2 power 5, 2 power 6 divided by 2 to the power 5, which is equals to 2. The approach is very simple, friends. The approach is going to be very simple. We just simplified it. We took LCM and we got in a standard form. Always make sure we know only these two prerequisites, alpha plus beta and alpha into beta. By using these two, we are getting everything. We are getting everything. Next question. Another important question. Even this is also a PYQ. See, friends, like alpha and beta are the roots of this equation. So what is the equation now? 2x into 2x, 4x square plus 2x into 1 plus 2x minus 1 equals to 0. If alpha and beta are the roots of this equation, what is alpha plus beta? Minus 2 by 4, which is equals to minus 1 by 2. From here I can write 2 alpha plus 2 beta is equals to minus 1. Clear, everyone? Now just alpha is a root, I can substitute alpha here. So 4 alpha square plus 2 alpha minus 1 is equals to 0. 4 alpha square plus 2 alpha minus 1 value is 2 alpha plus 2 beta is equals to 0. So 4 alpha square plus 4 alpha plus 2 beta is equals to 0. We can just take 2 out. So 2 alpha square plus 2 alpha plus beta is going to be 0. Then beta is going to be minus 2 alpha square minus 2 alpha minus 2 alpha common alpha plus 1. Very simple. We have just analyzed it, required this, and in place of minus 1 we have substituted it. Hope the thing is clear. Friends, again we are going to use PK they have given. PK they have given. Now by using this, very simple, na? Newton's formula. By Newton's formula we are going to get everything. First before applying Newton's formula, first we will be knowing like k greater than or equals to 1. First, what is P1? Alpha plus beta, which is equals to 1. P2, alpha square plus beta square. Alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. So that becomes P2 equals to alpha plus beta is 1 plus 2, again 1 plus 2. Alpha plus beta is 1 minus 2 times of minus 1. 1 plus 2, which is equals to 3. Clear, everyone? Then you can get even P3 too. P3 also you can get. What will be P3, friends? P3 is nothing but alpha cube plus beta cube. A cube plus B cube can be written as A plus B whole cube minus 3AB times A plus B. Everything you know. Alpha plus beta minus 1. Sorry, plus 1. 1 cube is going to be 1 minus 3 times of alpha beta minus 1 times alpha plus beta plus 1. So 1 plus 3, which is equals to 4. That's it, you know, friends. Like P1 you got, P2 you got, P3 you got. By using these three you can get everything. P4, to get P4 what happens? A times of P4, yeah, minus like plus B times of P3 plus C times of P2 is equals to 0. To get P4, A is 1, P4, B is minus 1, minus P3, but already P3 is 4, C times, that is again minus 1 times P2, P2 is again 3, minus 1 into 3, just minus 3 equals to 0. So P4 is equals to 7. Again we can get P5 too. Okay, which of the following statements is not true? They are asking. P3 is equals to P5 minus P4. P5 we didn't get P5. Okay, get P5 too. A times of P5 plus B times of P4 plus C times of P3 is going to be equals to 0. From here, A is on 1, P5 we don't know. So P5 plus B is again minus 1, minus times P4, minus 7, minus P3, P3 minus 4 is equals to 0. Hence P5 is equals to 7 plus 4, 11. Guys, we know P5, first one, P5 minus P4, 7 minus 11 minus 7, 4 we got. Yes, this is correct. Sum of all these equals to 26. 1, 4, 8, 19, 26. Even this is also correct. P5 is 11 correct. P5 is product of P2 and P3. No, this will be wrong. Understood? Just by using Newton's formula, we got everything, friends. So that's the importance, very important. The least positive value of A for which this equation has real roots. This equation is going to have real roots. What do you mean by that? A quadratic equation is going to have real roots. What do you mean by that? Discriminant. That's it. Only the discriminant of this quadratic equation is going to be 0. Greater than or equals to 0, just by using this, friends. But make sure you first write this in standard form. 2x square plus a plus 10 times x plus 33 by 2 minus 2a equals to 0. Now this will be our quadratic equation. Discriminant of this just take this inequality and get the value of a, friends. That's it, the least value of a. If you just simplify it, you will be getting it. So my dear friends, I am assigning you this for homework. Simple thing. Next, the number of integral values of m for which the equation equals to 0 has no real roots again. No real roots means, what do you mean by that? No real roots means all are imaginary. Imaginary roots means the discriminant of this particular quadratic equation is going to be less than 0. That's it, friend. This is only the thing which is required. This was asked in the year JEE 2019. How much simple they are asking from quadratic equation. You just try to analyze it. Very simple. Approach is simple. The approach is discriminant of this is going to be less than 0. Discriminant of this quadratic equation, that is b square minus 4ac, is less than 0. Just substitute a, b, c in this and get the value of this. But they are not asking you to get the solution of m. You will be getting m solution, like m belongs to some inequality region. You will be getting that from there. From that solution set, how many number of integers that you have in that particular solution set. So that is what they are asking. Just keep all your efforts in that and just do it. Very simple, friends. Take it as homework. Next, if one real root of the quadratic equation is cube of the other, then value of k is going to be simple again, very simple again. One root, like one root if it is alpha, the other root is going to be alpha cube. That's it. Now, see, alpha into alpha cube, product of the roots is going to be 256 divided by 81. Yes. So alpha power 4 is going to be 256 by 81. This can be written as 4 by 3 whole power 4 whole to the power 1 by 4. This can be actually written as plus or minus 4 by 3. You can even take plus 4 by 3 or minus 4 by 3 according to that. Next, sum of the roots alpha plus alpha cube is equals to minus k by 81. That's it. Just substitute 4 by 3 here. 4 by 3 plus 4 4 16, 16 4 64 divided by 27 is equals to minus k by 81. Now multiply 9 4 36 plus 64 divided by 27 is equals to minus k by 81. 9 3s, 9 9s, 3 1s, 3 3s. Like k is equals to negative 300. Do we have? Yes, we have. If you are not going to have, then you could have taken alpha is equals to minus 4 by 3. Understood, friends? And moreover, they didn't inform you anything regarding that the roots are going to be only positive. No. Okay, we can take alpha whether 4 by 3 or minus 4 by 3. We took 4 by 3 and we got k equals to negative 300. Next, we are done with the basic things of quadratic equations. Now the next concept that we are having in quadratic equations is common roots concept. Very simple concept, very simple. Two cases, friends. Like common roots means, like if you are going to consider two quadratic equations, one is a1x square plus b1x plus c1 is equals to 0, a2x square plus b2x plus c2 is equals to 0 are any two quadratic equations. Any two quadratic equations. Only one, if these two quadratic equations are having common roots, means there are two possible cases. One root can be possible or both the roots can be possible. Now let's go with first thing, that is one root possible. Let alpha comma beta be the roots of the first one and alpha comma gamma be the roots of the second one. Now this alpha is going to be the common root for both the equation. Here no need to remember any formula, nothing friends. Approach is simple. Whatever the you have to understand that you have to take an assumption that let alpha be the common root for both the equation. Okay, then you substitute alpha in both the equations. A1 alpha square plus B1 alpha plus C1 is equals to 0 and A2 alpha square plus B2 alpha plus C2 is equals to 0. Friends, that's it. Never remember anything. Only this. Let alpha be the common root. That's it. Substituting alpha in both the equations and just solving them. Solving them, you will be getting everything. Have you understood, my dear friends? Very, 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 very simple approach. Very simple approach. No need to remember any formula, no other nothing. Whenever they say that the two equations are having one root in common, just take this and simplify it. You can solve this too by using cross multiplication method. Now second case we are having is both roots common. Both roots common means, friends, like see, if I say a1x square plus b1x plus c1 is equals to 0. Okay, just imagine, just or like two equations. I'm just taking two equations. Both the like a1x square plus b1x plus c1 is equals to 0. Another equation a2x square plus b2x plus c2 is equals to 0. Even if the first equation has roots alpha comma beta and the second equation is also having roots, then this can be written as directly this quadratic equation a1 times x minus alpha into x minus beta will be 0. Yes, if roots are known, how do we get the quadratic equation? And the leading coefficient is a2 here. So a2 of x minus alpha into x minus beta is equals to 0. My dear friends, very simple thing. So if two quadratic equations have both the roots common, then their coefficients will be in proportional. The most important thing, then their coefficients will be in proportional. That is a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Very, 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 very important. That's it. Their coefficients are always proportional. Their coefficients are always proportional. Now let's do some particular problems on this concept. These two equations have one root common. In general, our procedure is we will be taking alpha as the common root, but now see, one equation can be factorized. This can be easily factorized in x minus 5 into x minus 2 0. That becomes x5 or 2. X can be either 5 or 2. See friends, now just if of these two roots alpha can be the common, 5 can be the common root or 2 can be the common root. If 5 is the common root, what happens? If 5 is going to be the common root, what happens? 5 square 25 minus 25 plus c equals to 0. So c can be either 0 or c can be either 0. If x square 2 square 4 minus 10 plus c, so c can be either 0 or 6. According to the options, we'll be taking a step. Clear? If these two equations have one root common, and then a is to, like this question was asked in the JEE 2014, friends. See, just common sense, friends, common sense, very, very common sense. What is the discriminant of this quadratic equation? D equals to 9 minus 4 4 16, 16 2 is 32, which is less than 0. That means what are the roots of this equation? Imaginary. Roots of this equation are imaginary. Imaginary, that too, all the coefficients are real numbers. If all the coefficients are imaginary, all are real numbers, then roots are imaginary and occur in pair. That means if one root is alpha, like one root is a plus one root is a plus ib, then the other root will be a minus ib. Clear? Now again coming here, They said all the coefficients are real here. All the coefficients are real here. In this case also, all the coefficients are real. So if all the coefficients are real, then if suppose of these two roots like a plus ib be 1, if all the coefficients are real, here also they occur in pair, no? So the other root will be a minus ib only. Understood, friends? Very simple thing. So that means they are not having one root common, both the roots are common. If both the roots are common, what happens? Their coefficients are proportional. That is a is to b is to c is equals to 2 is to 3 is to 4. So that much important basic concept is clear. Next, ABC is like AB belongs to capital R, A not equals to 0, has a repeated root alpha, then which is also a root of the equation. This asked in the year 2020. Beta is the other root of this equation. Then they are asking alpha square plus beta square value. Whatever with only the requirements will be going. See, friends, like ax square minus 2bx plus 5 is equals to 0. The roots of this equation are alpha and alpha, repeated root, na? So what happens? Alpha plus alpha is equals to alpha 2b by a, and alpha into alpha. Alpha square is equals to 5 by a. So 2 alpha is equals to 2b by a, alpha is equals to b by a. Okay, like just do understand. Alpha square is equals to 5 by, what is a here? B by alpha, na? From here a is b by alpha. Now alpha gets cancelled, alpha is equals to 5 by b we got. Let us keep this as one relation. Now, what is the other equation that we have? What is the other equation that we have? Other equation that we have is x square minus 2bx minus 10 equals to 0, and the roots of this are, one is alpha, the other is beta. So what is alpha plus beta? We have 2b, and alpha into beta is equals to minus 10. Friends, common sense. Alpha is equals to anyhow 5 by b, and here what is beta? Beta is equals to minus 10 by alpha. But what is alpha? Minus 10 by alpha is already 5 by b, no? So 5 into b, that is nothing but minus 2b. So 5 by b minus 2b is equals to 2b. 5 by b is equals to 4b. From here we get 4b square is equals to 5. Let's keep these two relations aside. Now they are asking alpha square plus beta square value. By using our just simple mathematical formula, alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. Yes, alpha plus beta is nothing but 2b. So 2b whole square minus 2 times of alpha beta. Friends, this is 4b square minus 2 alpha beta. Substitute all the part. 4b square is 5 minus 2 times alpha into beta value. So 20 plus 5, 25 is going to be our answer. Very simple, friends. We have not taken even much risk to. Get this particular thing. So all the given things, we have just simplified them. Clear? Good. Next thing. Next question. On alpha and beta are the roots of this equation, and alpha gamma are the roots of this particular equation. Acha, we have one root in common, friends. Okay, so alpha is the common root for them, that is x square minus x plus 2 lambda equals to 0. The roots of this are alpha comma beta, and the second equation is 3x square minus 10x plus 27 lambda. The roots of this are alpha comma gamma. Friends, alpha is the common root that we have. So put alpha square minus alpha plus 2 lambda. Next 3 alpha square minus 10 alpha plus 27 lambda is equals to 0. To get some relation, we can just multiply this with 3, then subtraction. What do we get, friends? 3 alpha square gets cancelled. Minus 3 alpha plus 10 alpha, 7 alpha plus 6 lambda minus 27. 6 minus 27 minus 21 lambda is equals to 0. Alpha is equals to 3 lambda we get. Clear? Yeah, yes, alpha is equals to 3 lambda. Okay, next product of the roots, what we got here? Product of the roots, alpha into beta is equals to 2 lambda and alpha into gamma is equals to, here we got 27 lambda by 3. So that means 9 lambda only. Okay, correct only? Yes, correct. Now we need like to get beta gamma, we just multiply these two, friends. So alpha square into beta gamma is equals to 9 2's 18 lambda square. But already alpha square is 9 times of lambda square. Yes, into beta gamma is equals to 18 lambda square. Lambda square, 9 1's 9 2's. Beta into gamma value is plus 2. Already we got alpha is equals to 3 lambda. Let us just try to substitute here. Okay. Now 9 lambda square minus 3 lambda plus 2 lambda. 9 lambda square minus 3 plus 2. Minus 3 plus 2 is minus lambda. Substitute alpha is equals to 3 lambda in this equation. 9 lambda square minus lambda is equals to 0. So that means either lambda will be equals to 0 or lambda will be equals to 1 by 9. Friends, lambda can't be 0. Yes, lambda has to be equals to 1 by 9 because lambda is in the denominator. Na? So beta gamma divided by beta gamma divided by lambda will be equals to plus 2 divided by 1 by 9, which is equals to 18. See how simple. This question was asked in the year 2020. Very simple, na? The only thing, my dear friends, I again tell you one most important thing here in this approach, friends. Identifying all the given things in a clear manner. And how can we correlate that given part with the required thing? That's it. There makes the sense. It's not like knowing everything but not able to apply in a proper way. Waste. Everything will go in vain. Clear? Next thing, x square plus px plus q and x square plus qx plus p is equals to 0 have one common root. Friends, let alpha be the common root. What happens then? Very simple, na? Alpha square plus p alpha plus q is equals to 0 and alpha square plus q alpha plus p is equals to 0. Subtraction, alpha of p minus q plus q minus p equals to 0. Then alpha is equals to p minus q, if this goes to that side, by p minus q. Alpha 1, just simple, put alpha like x in place of alpha. So one root is 1. Now put 1 here. So 1 plus p plus q is equals to 0. We got this. Ho gaya. And the other roots, now they are asking, show that their other roots are the roots of the equation of this. Acha, okay. See friends, like let this equation has roots. One is already 1, okay, 1 and beta, and this equation has roots 1 and gamma. Clear? Now product of the roots will take for the first one. What is the product of the roots? 1 into beta. So beta is equals to q. And the for second one, what is the product of the roots? Gamma is equals to p. Oh, we got it. We got the two roots. Now if you know two roots, the required equation x square minus x into p plus q plus pq is equals to 0. But already p plus q value is minus 1. So x square plus x plus pq is equals to 0. See friends, how simple we got it, na? How simple we got this particular required thing. Very simple. Clear? Next is as we are done with that particular part, common root concept. Now we are going with quadratic expression and its graph. Friends, like this particular concept we can say that heart of this particular everything. From now we will be discussing the range of thing also. Very, very, very important, friends. Very important. Quadratic expression and its graphs. Quadratic expression and its graphs. Do understand it. Do understand. Quadratic expression. Friends, now I take let y equals to ax square plus bx plus c is a quadratic expression. Now, the graph of this quadratic expression is going to be a parabola. Is the graph of this particular quadratic expression is always a parabola, second degree equation. Now, this can be like determined in two cases. Case 1, always like these two cases depends on the coefficient of x square. That is, the coefficient of x square, that is a, is positive. Then we say upward parabola. We say upward parabola. We say upward parabola. Upward parabola. The graph opens upwards. If the coefficient of x square is less than 0, negative, then we say downward parabola. The graph opens downwards. Like this. Like this, like this. Next. Suppose now in case 1, if I take, if the graph is going to be like this, friends, this particular point is called as turning point. Turning point means from here till here the graph is a downwarding graph. From here the graph is going to be like decreasing to increasing. So this is what the turning point of the graph we say, and like mathematically we say this particular turning point is called as vertex of the parabola. Vertex of the parabola. And the significance of vertex is, if you are going to draw a tangent at this vertex, if you are going to draw a tangent at this vertex, that tangent is going to be parallel to the x-axis. The tangent drawn at the vertex of the parabola will be parallel to the x-axis. If a line is parallel to the x-axis, what will be its slope? 0. So hence dy by dx will be equals to 0. The slope of the tangent drawn at vertex is going to be equals to 0. So that means we will be getting the coordinates of this particular vertex for the parabola y equals to ax square plus bx plus c just by equating dy by dx to 0. This, let's find it now. Let's differentiate both sides with respect to x. So dy by dx will be equals to ax square, that is 2ax plus b is equals to 0, which implies x is equals to minus b by 2a. If you substitute that x is equals to minus b by 2a, then we get x is equals to 4ac minus b square by 4a. In simple words, I can just write this as minus of b square minus 4ac. So that I write minus d by 4a. Hence the coordinates of the vertex, the parabola y is equals to ax square plus bx plus c is always minus b by 2a comma minus d by 4a. Friends, very important, very important. Minus b by 2a comma minus d by 4a. And this parabola will be always symmetric with respect to its axis. What is its axis, sir? The vertical line passing through the vertex. Nothing but x is equals to minus b by 2a. Since this is symmetric with respect to this line, so that's the reason if you are denoting this as f of x, friends, so f of minus b by 2a plus x is equals to f of minus b by 2a minus x. That means friends, if you are from this axis, if you are going to move x units to the left or x units to the right, y value is going to be same. This is the meaning of this particular symmetricity. Do understand, the graph of y is equals to ax square plus bx plus c is always symmetric with respect to its axis. And that axis is the vertical line. That axis is the vertical line passing through the vertex. Clear, everyone? Is that clear, friends? Absolutely good. Very good. So the coordinates of the vertex are minus b by 2a and the minus b by 2a comma minus d by 4a. This is what this. Next, next another important thing is, friends, very clear. Like now, again in the same way we'll be having like if a this case is a greater than 0 and the case a will be less than 0. Here, if you see, this graph is neither cutting, neither touching, nor intersecting the x-axis. Neither touching, nor intersecting the x-axis. Neither touching, nor intersecting the x-axis. That means the discriminant of this is less than 0. I'll tell you, friends. Friends, case 1, if a is greater than 0, then we'll see. A greater than 0, there are 3 possible cases. One is touching and intersecting x-axis, only touching x-axis, neither touching nor intersecting x-axis. In all the 3 cases, a greater than 0, but in this case, discriminant greater than 0, discriminant equals to 0, and discriminant is less than 0. In the second case, if you see a less than 0, discriminant is greater than 0 in this case, discriminant equals to 0, and discriminant less than 0. We have one good significance for a discriminant less than 0 that we will be discussing here in the next term. But so the relationship between the roots, like if discriminant greater than 0, that means 2 roots real and distinct. This is what we say, roots, 2 distinct real roots. If discriminant is equals to 0, we will be having only like repeated roots, we say. So if discriminant is less than 0, we won't be having any real roots. That means the graph is not touching x-axis. Clear? Only imaginary roots. Clear, everyone? Friends, clear? Is that clear? Now, so this is what regarding the graph of, and this particular point is vertex. Every graph of y is equals to x square plus bx plus c is always symmetric with respect to its axis. X is equals to minus b by 2a, and since it is being symmetric, so that's the reason why we say f of x, like x plus minus b by 2a minus b by 2a minus. That means like from what, from axis, if you are going x units to the left and you are going x units to the right, the value of y is going to be same. Value of y is going to be same. Value of y is going to be same. Good. Value of y is always going to be same. This is what f of y we say. Okay. And yes, next. Next. Before that, we can even like, how do we get the graph of a particular quadratic equation? Suppose we say y is equals to, ax square plus bx plus c. We have y is equals to ax square plus bx plus c. Plotting the graph of quadratic equation is very simple and we have to understand it, friends. There are only 3 possible cases. First thing, to draw the anything, first you should know the coefficient of x square, that is a. This always depends like sine of a. Okay, we should know sine of a. By that we can just understand that whether it is upward parabola or downward parabola. Next is vertex. When you get vertex, you also get axis. And number 3, y-intercept or c value. When x equals to 0, it cuts like. If you know these 3, then you get everything. Okay. I would like to draw a graph of like one particular example, friends. Like draw the graph of y is equals to x square plus 4x plus 6. Please do understand. First, the 3 cases. Sine of a. First one. What is the sine of a? Positive. That means upward parabola. Next, number 2, vertex. What is vertex? Minus b by 2a. So minus 4 by 2. Minus 2 comma minus 4. Next, find d. D equals to b square minus 4ac. 4 square 16 minus 24. 16 minus 24. minus 8. See, d less than 0, it is neither going to intersect nor, so minus d means 8 by 2, 4. Okay, from here what is the axis? You get x is equals to minus 2. This is axis. And third one is y intercept. Put x equals to 0, you get that is y equals to 6. That means c value, c equals to 6. That's it. If you know all these three, see how the graph is going to be very simple. You see, this is x-axis, this is y-axis. This is x-axis, this is y-axis. This is x-axis, this is y-axis. X-axis, y-axis. Now, plotting the points on this is very important. Please make sure you plot them properly. First thing, upward parabola. Next, plot this vertex. Where do we have vertex? Minus 2 comma plus 4. Minus 2 comma plus 4, somewhere we will be having it here, na? Okay, somewhere like minus 2 comma 4 it is. From here you can even draw the axis too, like, yeah. Axis helps in symmetry, friends. Okay, next c equals to 6, another point that we have, c equals to 6. Here we will be having somewhere our 0 comma 6. See, draw like something, it is like the turning point. This is how the graph of y is equals to x square, y is equals to x square plus 4x plus 6 is going to be. This axis like symmetrical from how much distance, like here also how much distance in that way. Friends, to draw the graph of any quadratic expression, three things: sine of a, vertex, y-intercept, that is the value of c. With these three we can draw the graph of any quadratic expression. Understood, friends? Have you all understood? You can even take some more examples too. Draw the x square plus 2x plus 1, or y is equals to minus x square plus 3x minus 2. Please try these two, friends, as homework. Okay, try these two as homework. Try drawing these two. Clear? First get sine of a, then vertex, plot the vertex, then y-intercept, plot the vertex. Next, join the curve like from negative extreme to positive extreme such that it is having its turning point at our vertex. That's it. Clear all? Yes, I hope it is clear. Next, we have one great significance when the quadratic expression has discriminant less than. Suppose I take like f of x is equals to ax square plus bx plus c, friends. Two cases, a less than 0, a greater than. First case, like a greater than 0 if I take. Since a greater than 0, the graph is neither going to touch nor going to intersect the x-axis, and it will be always lie above x-axis. Okay, and this is our vertex, minus b by 2a comma minus d by 4a. And case 2 if you take, friends, the graph is going to be like this. Somewhere here we'll be having our vertex minus b by 2a comma minus d by 4a. Here do understand one thing. When a is greater than 0, see, this curve is completely lying above x-axis. So ax square plus bx plus c, that is f of x, is always positive when a is positive. And when a is negative, f of x is always negative. F of x is always negative. So that means, friends, even the sign of c also, like if you just understand, when d is less than 0, the sign of a, f of x, c will be same. When d discriminant of a quadratic equation is less than 0, the sign of a, c and f of x, even the quadratic expression sign. So for that we can say, friends, like f of x f of x will be greater than 0 if a greater than 0 and f of x is less than 0 if a less than 0 when discriminant of the quadratic equation is less than 0. Friends, very important. Please make sure you are understanding these two. Clear? F of x will be positive if a is positive. F of x is negative, means the sign of the quadratic expression and a remains same. Very important. We get such result. Okay, they will be asking you like they will be giving you a quadratic expression and that is always positive. Get the values of so and so. If a quadratic expression is positive, means what is the first approach that we have to take? Discriminant of it is less than 0, or negative, discriminant of that is less than 0. Clear? Next, maximum and minimum value of quadratic expression. Just now we have seen, friends. Like again, the graph of quadratic, if you say like this one, a greater than 0 and a less than 0. Irrespective of the discriminant, whether like, see, whether intersecting x-axis or touching x-axis or neither touching nor intersecting, all the three cases, I am going to give you a like final conclusion. See friends, final conclusion. Always this particular point is our vertex, minus b by 2a comma minus d by 4a. Again vertex, here vertex we have minus b by 2a comma minus d by 4a. This point is again our vertex. This is again vertex. In all the possible cases you see friends, like now you consider a greater than 0. The graph is completely lying above vertex point. That means range of this particular quadratic expression, range of y is equals to ax square plus bx plus c is going to be y belongs to like case 1. If I say case 1, if a is greater than 0, then y belongs to, from where we are starting, see, this is the minimum we have, so no maximum. When a is positive, only we will be having minimum, and maximum is infinity. Maximum is infinity. That means from minus b by 2a, sorry, y coordinate is minus d by 4a, na? From minus d by 4a to infinity. And all these cases, the minimum value of y is going to be minus d by 4a. Understood friends? The minimum value of y is going to be minus d by 4a. Y minimum is equals to minus d by 4a. Or I can just write it here so that it will be visible. And y minimum, we are going to have only minimum, and that minimum is going to be minus d by 4a. Coming to case 2 friends, case 2, if a is less than 0, the graph opens downwards. See, we are having only maximum point and minimum approaches to negative infinity. Therefore, the range of this expression is going to be from negative infinity to the maximum is going to be minus d by 4a. So y max in this case is minus d by 4a. Friends, very simple logic. The range of a quadratic expression, that is maximum and minimum value of a quadratic expression, is going to be obtained in this particular form. Is it clear friends? Is this clear? Is this clear? Please take this, please take this, please take this. The range of the quadratic expression, very simple and very easy. Next, maximum and minimum values of rational algebraic expression. All the cases I'll tell you a beautiful technique, friends. Whether it is a quadratic by quadratic, or 1 by quadratic, or a linear by quadratic, or a quadratic by linear expression, any expression you take, friends, any expression you take, the approach that we are going to do is very simple. What we'll be doing is we'll be just taking y is equals to that expression. Okay, now just see, like instead quadratic by quadratic, or we'll go with one example. Process is very simple. Process is going to be very simple. How? Suppose, let me take an example. Find the range of, or maximum minimum values, or get the range of this expression, x square plus x plus 2 whole divided by x square plus x plus 1. Clear? We got like quadratic by quadratic. Anything, friends, it's like not quadratic by 1 by quadratic or linear by quadratic by whatever they give you the expression, they'll be giving you like this. Find the range of, like find the range of such expression for all x belongs to capital R. They give you this, friends. They give you this. This is the most important thing for us. For all x belongs to capital R. Now we know, you know what? We'll be just taking, agenda is very simple. Approach is going to be very simple. What is that particular approach is? We just take, we put y is equals to this one, x square plus x plus 2 whole divided by x square plus x plus 1. X square plus x plus 2 whole divided by x square plus x plus 1. Okay, now just transform this equation as a quadratic in terms of x. Okay, simple quadratic. So yx square plus yx plus 1 is equals to yx square plus, not yx square, is equals to x square plus x plus 2. The most simple one, friends. Now just take x square of, simplify it, plus x of y minus 1 plus y minus 2 is equals to 0. Is equals to 0. Is equals to 0. Now just do understand this thing. Do understand this thing. Do understand this thing, friends. I am audible now? Friends, am I audible? Good. So now the thing is, this is a quadratic equation in terms of x. This is a quadratic equation in terms of x. But they have given x is a real number. Since x is a real number, the roots are going to be real. That means the discriminant of this equation is going to be 0. This is the fundamental approach or the problem solving skill. This is like the most important thing for this, even d greater than or equals to 0, friends. That's it. I hope you all have understood this one. Is that clear? Now d should be greater than or equals to 0. What is d, friends? B square minus 4ac. B square y minus 1 whole square greater than or equals to 4 times of ac, y minus 1 into y minus 2. That becomes y square minus 2y plus 1 greater than or equals to 4 times y square minus 3y plus 2. So y square minus 4y square minus 3y square minus 2y plus 12y plus 10y plus 7 minus 7. Minus 3y square plus 10y minus 7 is greater than or equals to 0. Just multiply with the negative sign. Then we get 3y square minus 10y plus 7 is going to be less than or equals to 0. 7 3 is 21. That becomes 3y square. We can write this as minus 3y minus 7y plus 7 less than or equals to 0. So 3y common. 3y of y minus 1 into minus 7 of y minus 1 less than or equals to 0. that becomes y minus 1 into 3y minus 7 less than or equals to 0. Hence friends, finally if you are going to take wavy curve, then from there y belongs to closed 1 to 7 by 3 you get. But wait, ruko. Here comes the most important part. Very important part here is, once you get that solution, here what is the coefficient of x square? Y minus 1. Just equate the coefficient of x square to 0. Okay, that means equate y minus 1 to 0. What you got? We got y equals to 1. Clear? Y equals to 1. Now check, this 1 is a part of it or not. Yes, this is a part of it. Now since it is a part, see friends, like if you put y equals to 1 here, what happens? Just common sense. X square plus x plus 2 is equals to x square plus x plus 1. X square, x 2 equals to 1 we got. Can 2 be equals to 1? When friends, after getting that result, equate the coefficient of x square to 0. We got y value. 1. Check the value whether it lies in our final range or not. If it lies, then substitute in the given part. We got some absurd relation. If you are getting an absurd relation, eliminate that particular. Hence the final range of this is going to be open 1 to open 7 by 3 friends. This is how we get. Very simple. In all the cases, we just take y is equals to that expression. We express in terms of quadratic equation in terms of x. That's it. We simplify. We get the value of y. Finally, we equate the coefficient of x square to 0. We'll be getting one y value. That y value, whether it lies in our range or not. If it lies, we'll be checking here. Is it resulting in an absurd relation? Absurd relation means some meaningless relation. See, meaningless relation means something like 2 equals to 1. This is, instead that if we got something like 1 equals to 1 or 0 equals to 0, we could have included that. So always check the coefficient of x square, equate it to 0, corresponding that you will be getting it. Friends, have you all understood? Have you all understood? Such a beautiful topic it is. Okay. Next. Let's do some PYQs based on this particular nature. The integer k for which this inequality is valid for, see friends, a quadratic expression is positive. What do you mean by this? A quadratic expression is positive, always positive. That means that too, coefficient of x square is also positive, no? So hence the discriminant of this is less than 0. That's it. Only this particular thing. That's it. So what is the discriminant? B square, 4 times of 3k minus 1 whole square is less than 4ac, 4 times of 8k square minus 7. 4 times of 8k square minus 7. That's it. 3k minus 1 whole square is 9k square plus 1 minus 6k less than 8k square minus 7. Everything to this side. So k square minus 6k 1 plus 7 plus 8 less than 0. So that becomes k minus 2 into k minus 4 less than 0. K belongs to 2 comma 4 open. But what is asking? Integer is asking. What is the integer which lies in this region? Which is equals to the integer which lies in the interval open 2 comma 4 is going to be 3. See friends, this quadratic expression is positive. Positive means completely lying above x-axis. So no touching nor intersecting x-axis. That means discriminant. See, this is what the problem solving step. Next. If m is chosen in the quadratic equation so and so such that the sum of its roots is greatest. Acha. Sum of its roots. Let alpha be the roots of this particular quadratic equation. Then what happens to alpha plus beta friends? Minus b by a. 3 by m square plus 1. Oh my god. This is, see, when this will be greatest friends? When this will be greatest, the denominator is least. When will be the denominator least? For which value of m? M equals to 0. That's it. then alpha plus beta will be 3. Put m equals to 0 in this equation. So x square minus 3x plus 1 is equals to 0. This will be our equation. Now in the absolute difference of the cubes of the roots they are asking. They are asking mod of alpha cube minus beta cube. Friends, I request you to do this because there is nothing in it. We already got the quadratic equation, final quadratic equation. This is not related to range, but generally a normal thing. A cube minus b cube, that is a minus b into a square plus b square plus ab. We can get alpha minus beta, we can get alpha square plus beta square, we can get alpha beta, substituting everything. What we know? We know alpha plus beta and alpha beta. What is alpha plus beta? We have 3 and alpha into beta we have 1. From this to get this. Can you all do it? Say yes. Yes. Please make sure you do it. But see, the only thing here is identifying the m value. For which value of m this whole term will be the greatest one. That's it. Now coming to the next question, the value of lambda for which the roots of this quadratic equation has the least value. First friends, the most important thing here is, here we have lambda. Majority of the students they will be taking only this part as quadratic equation. Okay, first get the lambda to the left hand side. That is x square plus 3 minus lambda times x plus 2 minus lambda is equals to 0. Now they said like sum of the squares alpha square plus sum of the squares of the roots. That is we know already alpha plus beta whole square minus 2 alpha beta. This is equals to alpha plus beta means 3 minus lambda whole square minus 2 times of 2 minus lambda. 9 plus lambda square minus 6 lambda minus 4 plus 2 lambda. Finally, lambda square minus 4 lambda, 9 minus 4 plus 5. Friends, this can be written as lambda square minus 4 lambda plus 4 plus 1. So, this can be written as lambda minus 2 whole square plus 1. Friends, very simple. When will be the least? If this part is 0. When will this part be 0? Lambda equals to 2. That's it. What a simple question it is, friends. Very simple question. Same approach we are following. Next, lambda be the ratio. This question was asked in the JEE 2019. Lambda be the ratio of the roots. So if we take alpha and beta, then lambda will become alpha by beta. That's it. Quadratic equation m square, then the least value of m for which this equals to 1. Acha. See, we have alpha by beta plus 1 by lambda becomes beta by alpha is equals to 1. That becomes alpha square plus beta square is equals to alpha beta. What is alpha square plus beta square? Alpha plus beta whole square minus 2 alpha beta. That becomes 3 alpha beta. Now let us substitute everything here. What is alpha plus beta? Sum of the roots. M into m minus 4 by 3m square. You can take minus m, but already whole square no, so no, not necessary. 3 times of alpha beta. What is alpha beta? 2 by 3m square. 3 gets cancelled. Now mm gets cancelled here. Acha. So m minus 4 whole square divided by 9m square is going to be 2 by m square. M square gets cancelled. M minus 4 whole square is equals to 18. 9 2s are 18. That's it. Simplify it, friends. Simplify, get the value of m. That's it. There is nothing in it. So m square plus 16 minus 8m is going to be 18. Okay. And one more thing. Yes. Yeah. So m square minus 8m minus 2 equals to 0. Then the least value of m they are asking. See friends, there is nothing in it. Now we can just factorize this. Okay. After factorizing, after factorizing, not factorize, like m is equals to minus b plus or minus b square minus 4ac. b square 16, 64 plus 8 whole divided by 2, b square plus 4ac. m equals to 8 plus or minus 64 plus 8, 72. 72 can be written as 72 can be written as whole divided by 2. So 9 8s are 72. That means nothing. 36 2s are, yeah, 36 2s are we get. Clear? So m is equals to 8 plus or minus 36 2 means 6 root 2 whole divided by 2. That becomes 4 plus or minus 3 root 2. The least value means 4 minus 3 root 2. Two values of m we got. 4 plus 3 root 2, 4 minus 3 root 2. The least value means 4 minus 3 root 2. See friends, very simple. Everything. We are just getting some correlation between the given and required one by using our concepts of quadratic expression. The number of integral values of m, this is always, see, one expression is always going to be positive. When will the expression be positive, friends? One thing, the coefficient of x square should be greater than 0 and discriminant should be less than 0. So 2m, like m will be greater than minus 1 by 2 and discriminant less than 0. From here you will be getting an inequation in m. Friends, you will be getting an inequation in m, something less than 0. Now after getting the solution, take the intersection of these two, and you will be getting the required number of integral values. I am assigning you this particular problem as homework. Please complete this as homework. Friends, simple. The coefficient of x square positive, discriminant less than 0. If you simplify that discriminant less than 0, you will be getting solution like inequality relation you will be getting in terms of m. From there you get m also. Now once you get the intersection of these two, in that region how many number of integral solutions you have, that is what our answer. And this was asked in the 2019. I want everyone to do it. Coming to the next question. Question number 6. See, if f of x is equals to x square plus 2bx plus 2c square and g of x they have given are such that minimum of f of x is greater than maximum of g of x, then the relationship between b and c they are talking about. Just common sense, friends. Like already in quadratic expressions we have seen, like the graph of ax square plus bx plus c will be having only minimum if the coefficient of x square is positive, and will be having maximum if the coefficient of x square is going to be negative. And whether it is minimum or maximum always depends on the coefficient of x square, and that is same like minus d by 4a. Now let's do understand what is the minimum of this, minimum of f of x. What is minimum of f of x? As the coefficient of x square is positive, we will be having only, yes, this minimum is going to be minus d by 4a. And what is our d? Minus of d is nothing but 4b square minus 4ac. So 4 to 8c square. That's it. Whole divided by 4a. 4 into 1. 4. Clear all? Now we can just take minus 4 common. So or even we can even multiply negative inside. Then that becomes 8c square minus 4b square whole divided by plus 4, which will be equals to 4 common, then 2c square minus b square whole divided by 4. Finally we get 2c square minus b square. Stay tuned to it. Next, what about maximum of g of x, friends? Maximum of g of x is going to be same like minus d by 4a, but here minus of, what is d here? 4c square 4 minus of minus plus 4b square whole divided by 4a. 4 into negative 1 minus 4. Clear? Negative gets cancelled. Then that becomes 4 common, 4 of b square plus c square whole divided by 4. 4 common, finally we get b square plus c square. Now let's substitute these two in this particular equation. Okay, so minimum of f of x, that's it, from implies minimum of f of x given part is minimum of f of x is going to be greater than maximum of g of x. So what is minimum of f of x? Minimum of f of x is nothing but 2c square minus b square is greater than b square plus c square, which implies, friends, c square greater than b square plus b square 2b square, hence like c square greater than 2b square or 2b square less than c square. This is what the relationship between b and c. See friends, such an easy question. Okay, the next question, the seventh question. X square plus a minus b into x, they have given a quadratic equation where a comma b are two real numbers. Find the condition on a for which both roots of the equation are real and unequal. Both roots of a quadratic equation are real and unequal. That means the discriminant of this particular quadratic equation is going to be greater than 0. The first condition. So for first one, discriminant is greater than 0. What is discriminant? B square minus 4ac. B square a minus b whole square is greater than, directly it's greater than 4 into 1 minus a minus b. So that becomes, friends, a square plus b square minus 2ab greater than 4 minus 4a minus 4b. Let's bring everything to the left hand side. So we write b square plus b of, here 4 we have, minus 2a, then coming to a square plus 4a minus 4 is greater than 0. Now friends, this is a quadratic expression in b. As this is a quadratic expression in b, and b belongs to capital R. B always belongs to capital R, and this quadratic expression sign is always going to be positive. Means what can we conclude from here? The discriminant of this expression is going to be negative. That is what the most important step in this. So let's take d1. Some d1 is less than 0. The discriminant of this equation, that implies b square, you can take 2 common, 4 of 2 minus a whole square is less than 4 times this one, 4ac. 4 times a square plus 4a minus 4. That becomes 4 gets cancelled. A minus 2 whole square will be a square plus 4 minus 4a. A square plus 4 minus 4a is less than a square plus 4a minus 4. A square gets cancelled. From here, what can we get, friends? 4 minus 4, 8. 8 minus 8a is going to be less than 0, which implies 8a minus 8 is going to be greater than 0. A minus 1 is greater than 0, which implies a belongs to open 1 to infinity. This is the set of values of a for which both roots of the equation are real and unequal. This is how we did, friends. Awesome, na? Next, in the same way, coming to this, roots are imaginary. So first you will be taking discriminant of this quadratic equation less than 0. Then again you will be getting a quadratic expression in terms of b. For that, make sure you take d1 less than 0 that comes ho gaya. There ends our complete part. So I'll just give you this second part, only this exclusively second part as homework. Please make sure you are completing it on your own. Clear? So with this, we are done with the root part. Now the most important chapter, the most important conceptual part. Even in JEE Mains they have started asking questions on this. Very important concept that we have in our quadratic equation is location of roots. In total we will be having 7 cases, friends. So then, remembering the results of these 7 cases, just try to understand the condition and analyze the graph. That's it. So based on that, we have some necessary conditions according each case. So if you are enough good with remembering these cases or like analyzing these cases, it's enough. The most important thing is analyzing the conditions in each and every case. Location of roots. In the name itself, it is very clear that according to the given necessary conditions where the roots are going to be located. Okay, clear. Now just look friends, yes. Now for all these things, let me consider one particular thing. Let f of x is equals to ax square plus bx plus c, a general quadratic expression, okay, having roots alpha comma beta if exists. See friends, now location of roots in that case 1. First case, when both the roots are greater than k, what can be the possible conditions friends? Like see, for this, if a is greater than 0, I can draw the graph in this particular way. A greater than 0 in the sense, and a less than 0 I write here. So both the roots greater than k means, like I can say this, both the roots greater than k means whether roots are real and distinct, or even I can write roots are real and equal. So these are the two possible cases I can write. A less than 0, a greater than 0. Now do understand one thing friends. If both the roots are greater than k, let me take here alpha, here beta. That means here alpha, here beta, alpha less than beta. Both the roots are greater than a real number k means k should lie to the left of alpha. So somewhere here we have our k. K should lie to the left of alpha. Do understand. Now if I am just see, this particular value is going to be our f of k. This is going to be f of k. Here f of k is negative, here f of k is positive, okay, and somewhere here we'll be having our vertex. So the necessary conditions, like whenever we come across this particular case, what are the conditions that we can frame friends? What are the conditions that we can frame? Conditions, very important. Number one, see, discriminant of this should be greater than or equals to 0, the first condition. Number 2, as k lies to the left of alpha comma beta, here our vertex, now what is our x coordinate of our vertex? Minus b by 2a. This x coordinate has to be greater than k, that is minus b by 2a should be greater than k. And point number 3, which is very important, here a positive, f of k positive, a negative, f of k negative. So can we write a into f of k greater than 0 irrespective of a we get friends. So we'll be analyzing these three conditions with three different solutions we get. Once we take the common intersection in these two. There we get the final exact solution that we require. Intersection of all these three we are supposed to take. Intersection, please mind it again. Intersection of all these three. Clear? Next we'll go. When both roots are less than k, this is case 2. When both roots are greater than k, when both roots are less than k. Same friends, in the same way again, we have f of x is equals to ax square plus bx plus c. In that, a greater than 0, a less than 0, as usual. If I say both roots are greater than, both roots are less than k, so that means if I say here alpha, beta, k should lie to the right of beta. That means somewhere here if I take k, here if I take k. See friends, like almost like whatever the cases that I have taken in the previous case, all matches. F of k is positive, here f of k is negative. See the conditions, coming to the conditions. first condition is discriminant should be greater than or equals to 0. Clear? Friends, in some cases they give you like both roots are real and distinct. In that case, make sure you take only greater than 0. Okay. Number 2, see the vertex lies to the left of this real number k. Hence, minus b by 2a will be less than k. Whereas in the previous case, we have written minus b by 2a greater than k. Here, as both the roots are less than k, we write this. And third point is, as usual, a into f of k is greater than 0. So, friends, now finding all these and taking the intersection of these three, friends. Intersection, very, very important. Common region we need. Only the common region satisfies all the three conditions. Next. Third case, when k lies between the roots. So, same again, suppose a greater than 0 we take. A less than 0. When k lies between both the roots, so here alpha, here beta, here alpha, here beta, somewhere here k, here f of k is going to be less than 0, here f of k is going to be greater than 0, somewhere if here is k. That's it. We don't need any other. So here only one particular condition that we have, and that condition is in case number 3 is going to be when k lies between both the roots. K can be anywhere in between alpha to beta. So only one particular condition, a into f of k, a positive, f of k negative, will be less than 0, friends. That's it. Only one single condition. That satisfies here. That's it. Next, when exactly one root between k1 and k2. When exactly one root lies between k1 and k2. So I take a greater than 0. How can I draw the graph? This case is very important, friends. Like most of the times we have got these results. Very important. So a greater than 0, a less than 0. A greater than 0, I can draw the graph as like, see, when exactly one root lies between these two means alpha comma beta here, alpha comma beta. When exactly one root lies between, so if I take, let alpha be the root, that root is lying in between alpha k1 and k2. So here k1 I can take, here k2. F of k1 positive, f of k2 negative. If I take for this k1, f of k1 negative, but f of k2 positive. In this case, so only one particular condition we require in this, friends, and that condition is going to be, that is nothing but f of k1 into f of k2 is going to be less than 0, because both are having opposite sign. Very, very, very important, friends. When exactly one root lie in between k1 and k2, this condition is very important. See, are you all able to follow, understand? That's good. Very good. Next one, when k1 and k2 lies between both roots. When k1 and k2 lies between both the roots, both the roots. So I take two cases, a greater than 0, next a less than 0, a greater than 0, take a less than 0. If I say this, friends, like alpha, I have beta here, alpha, beta. When k1 and k2 lie between both the roots. So K1 here friends, K2 is going to be here. K1 here again, K2 here again. See, if you are going to take the condition that f of K1 into f of K2 positive, because here f of K1 negative, f of K2 negative, f of K1 positive, f of K2 is also positive. But you can't take the condition as like f of K1 into f of K2 positive, because the same condition, see if K1 here, K2 here, again that varies. So for that, the condition that we can frame is the condition. First, number one, a into f of K1, a into f of K1, a into f of K1 is less than 0. Number two also, a into f of K2 less than 0. After finding these two, get the common intersection of these two. Understood friends? Common solution only gives us the exact result. Next, case 6, when both roots lie in between K1 and K2. Oh, very important again. Case 6, again a greater than 0, a less than 0, a greater than 0, a less than 0. Clear all? Now see, just try to analyze this. Analyzing this is very important. Alpha, beta, alpha, beta. When both the roots lie between K1 and K2, so that means somewhere we have K1 here and somewhere we have K2 here. Somewhere we have K1 here. Let us take K1 less than K2. Okay? Friends, very important. Very, very, very important. Now just do understand this thing. What will be f of K1 positive, f of K2 positive, f of K1 negative, f of K2 negative. And one more important condition should be like our x coordinate of the vertex should lie in between these two. Our x coordinate of the vertex should lie in between these two. So conditions that I can frame are: Number one, discriminant should be greater than or equals to 0. Number two, K1 less than minus b by 2a less than K2. That is, x coordinate of the vertex is going to be in that way. Next, at the same time, a into f of K1 should be positive. Number 4, a into f of K2 also positive. Now friends, after getting all these 4 cases, getting the intersection in this intersection of all these 4 solutions will give us the location where this particular condition is going to be satisfied. Next, last case friends, when one root lies between K1 and K2 and other root lie in, see already we have seen such case, like exactly one root, case 4, exactly one root lie in between, the other root is lying between K2 and K3. The same rule that we are going to do here now. A greater than 0. See, for everything friends, for all of these 7 cases, by using graph I am explaining. So make sure you understand it and analyze it. A greater than 0, A less than 0, so somewhere here we'll be having our alpha, beta. What is the condition now? One root lie in between K1 and K2. So let alpha be the root which lie in between K1 and K2 and beta be the root which lie in between K2 and K3. So here K1, K2, K3. If you just understand this thing, If you just understand this thing, what is f of k1? Positive, f of k2 negative, f of k3 positive, f of k1 in this case negative, positive, negative. So I can just exclude you of those, like the case that we had already discussed in case 4. Number 1, f of k1 into f of k2 should be less than 0. Next, f of k2 into f of k3 less than 0. After getting these two, you find the common solution of this, common solution. So that's it, friends. So this is regarding location of roots. In total we have 7 cases. Friends, it's hard to remember, but it's very easy for us to analyze them. Based on analyzing, we can just, graphical approach is very simple, because in each and every case, condition, getting the condition, required condition is going to be very, very, very important. Okay, cool. Now we'll be discussing some problems based on these location of roots. Yeah, the first question 1 is going to be like, let x square minus m minus 3 of x plus m equals to 0 for all m belongs to R be a quadratic equation, then find the values of m for which both the roots are greater than 2. Friends, this is the first case that we had. Both the roots are greater than k. Here our k is nothing but 2. Okay, so just applying them. What are the conditions that we have? First case, for case 1, d should be greater than or equals to 0. Number 2, minus b by 2a should be greater than our k. Next, case 3, a into f of k, should be positive. Now taking all these cases and just taking the common solution of those, finally d greater than or equals to 0. What is d, friends? First discriminant, b square minus 4ac, m minus 3 whole square minus 4m, m minus 3 whole square minus 4m should be greater than or equals to 0. So m square plus 9 minus 6m minus 4m greater than or equals to 0. m square minus 10m plus 9 greater than or equals to 0. So m minus 1 into m minus 9 greater than or equals to 0. Clear? This can be factorized as m square minus m minus 9m. So finally we get m minus 1 into m minus 9 greater than or equals to 0. That means we get m belongs to closed minus infinity to 1 union closed 9 to infinity. The solution directly I am writing. Okay, this is case 1 solution. Now second case is minus b by 2a greater than k. What is our minus b by 2a? So m minus 3 whole divided by 2 greater than, what is our k here? Also 2. m minus 3 greater than 4, m is greater than 7. This is our second case solution. Now coming to the third case. Next one, third question. If both the roots of the quadratic equation, are real and distinct. See, real and distinct they have already mentioned. If they are real and distinct, what do you mean by that? Discriminant is not greater than or equals to 0. Discriminant should be greater than 0. And they lie in the interval. See, both roots lie in the interval. Which case it is? Case 6. Both roots lie in between k1 and k2. So discriminant greater than 0. Next, what are the conditions that we have? k1 less than minus b by 2a less than minus k2. Next, third condition, a into f of k, f of k1 positive, a into f of k2 positive. Case 6, friends. Case 6. When both the roots lie in between k1 and k2, discriminant should be greater. Here we have taken greater than or equals to 0, but this informed us that roots are real and distinct. So that means only greater than 0. K1 minus b by 2 a line between K1 and K2, a into f of K1 positive, a into f of K2 positive. So now identify, like, getting all these four cases and get the common solution by taking the common region of these four. So d greater than 0 d greater than or equals d just greater than 0, that is b square m square minus 4 is greater than 0. M plus 2 into m minus 2 greater than 0. That means m belongs to minus infinity to 2 union minus infinity to minus 2 union 2 to infinity. This is the first case. Next is K1. What is K1 here? 1 less than minus b by 2a, m by 2 less than K2, 5. Multiply with the 2. 2 less than m less than 10. Okay. Next, third case, a into f of K1. A is 1 anyhow. What f of K1 is 1. So 1 plus 4. 5 minus m should be greater than 0. M minus 5 should be less than 0. M is less than 5. Next case, a is 1 again. F of K2 means 5. So 25 minus 5m plus 4 greater than 0. 29 minus 5m greater than 0. 5m minus 29 less than 0, m less than 29 by 5. We can exclude this. You know why? Already m less than 5, m less than 29 by 5 means m less than 5 only will be taking. Now take the common solution for all these. Common solution. Friends, identifying common solution is very important. Mark all the critical points on the number line. Minus 2, plus 2, 5, 10. I'm not taking that, friends, because already that region is in this itself, because the common region of these two is this only. So now first is minus infinity to minus 2 union 2 to infinity. Next is 2 to 10. Okay. Next, less than 5. In all these, after saying all these, friends, that means the region, the required region that you are supposed to get is m belongs to open 2 to open 5. Is that clear, friends? Is this clear? Is this clear? See, very simple. First, make sure, friends, which case. See, this is case 6. Case 6. Identifying case and getting these conditions important. These conditions, these four conditions, very important. Identifying the case and getting these four conditions. Just substituting, and last getting the final by taking the intersection of all four is very, 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 very easy thing, friends. Very easy if you understand. Next. Now coming to the another most important thing. Last but one concept of today's session is going to be theory of equations. See, theory of equations in general, whatever the theory regarding equations that we have discussed in our earlier grades, that's it. Very cool, very clear. See, suppose in general we know now, friends, like considering a quadratic equation, if alpha comma beta are the roots of this, what can we say? Sum of the roots minus b by a, product of the root c by a. That's it. Next, cubic equation, ax cube plus bx square plus cx plus d. Sum of, if alpha, beta, gamma are three roots, sum of the roots minus b by a, sum of the product of the roots taken two at a time, c by a, and product of all the roots will be equals to minus d by a. Take for a biquadratic equation, just analyzing them, friends. Ax power 4 plus bx cube plus cx square plus dx plus e is equals to 0. Analyzing them. analyzing them, friends. Sum of the roots. Alpha plus beta plus gamma plus delta. Let these four be the roots. Minus b by a. Sum of the product of the roots taken two at a time. Two at a time. That means alpha beta plus alpha gamma plus alpha delta. Next beta gamma, beta delta. 1, 2, 3, 4, 5. Next gamma delta. See, 4 out of 4 we are selecting 2. 4C2. 1, 2, 3, 4, 5, 6 is equals to C by A. Next, sum of the product of the roots taken 3 at a time. Alpha, beta, gamma, alpha, beta, gamma plus alpha, beta, delta plus beta, gamma, delta plus alpha, gamma, delta is equals to minus D by A. And product of all the four roots is equals to E by A. Friends, we can just generalize this particular polynomial, generalize for nth roots, for nth degree polynomial, for nth degree equation, or even like if alpha 1, alpha 2, alpha 3 and so on, alpha power n, alpha n are going to be n roots of a equation. See friends, like now just do understand this. Do understand this. Suppose I have an equation an into x power n plus an minus 1 into x to the power n minus 1 plus an minus 2 into x to the power n minus 2 and so on and so on. a1x plus a0 is equals to 0. This equation is having n roots, and the n roots are alpha 1, alpha 2, alpha 3, alpha 4 and so on. Alpha n are the roots of this equation. Roots of this equation. Friends, so if we have the roots, like how can we generalize? First thing, sum of the roots taken one at a time. That means sigma alpha 1. Sigma alpha 1 is going to be, do understand, how many we took at once? 1. So minus 1 whole to the power 1 times, just one step ahead. 1 no, so you will be moving one step, that is coefficient of an minus 1 divided by an. Sum of the product of the roots, taken 2 at a time, that is sigma alpha 1 into alpha 2. How many we took? 2 into 2 steps from here. an minus 2 whole divided by an. Sum of the product of the roots taken 3 at a time. Alpha 1, alpha 2, alpha 3. How many we took? That has to be from here 3 steps. an minus 3 whole divided by an. In that way, friends, like all the product alpha 1 into alpha 2 into alpha 3 and so on, alpha n, we get like minus 1 whole to the power n into n steps, we get a0 divided by an. So this is how we can generalize the theory of equations. Theory of equations for nth degree equation having roots, n roots, alpha 1, alpha 2 and so on, alpha n. Yes. Now yes, some basic things regarding this, friends, like if alpha is a root of the equation f of, then the polynomial f of x exactly divisible by x minus, that is what factor theorem we say, factor theorem. Every equation of nth degree has exactly n roots. N roots, if it has more than n roots, then we say it has identity. If the coefficients of the equation f of x are all real, that is what we have discussed nature quadratic expression time, are all real, alpha plus I beta is its root, then alpha minus I beta is going to be the other root. Only when all the coefficients are all real, friends. Imaginary roots occur in conjugate, friends, and this point is very important, friends. An equation of odd degree will have odd number of real roots. An equation will have an even degree will be having even number of real roots. Suppose if I say equation of fifth degree equation will be having either one real root or 3 real roots or all the 5 real roots. Understood? Suppose fourth degree equation either we have 0 real roots or 2 real roots or 4 real roots, in that way. And if the coefficients in the equation are all rational and alpha, so that is what we have discussed, discriminant non-perfect square and the coefficients are rational, then irrational roots, that too they occur in pair. They occur in pair. They occur in pair. Next, this point is very important. Friends, if there be any two real numbers a and b such that f of a into f of b are of opposite signs, then f of x is equals to 0 must have odd number of real roots between a and b. What do you mean by this? Odd number of real roots. Suppose we understand for quadratic. Here if you take a, here if you take b, what is f of a? Positive. F of b? Negative. Nah? So f of a and f of b are of opposite sign, means in between them, see here we have one root, one real root. One real root. Now we have instead taking for quadratic like some another curve we take. Okay. Now let us consider, see a here if I am taking f of a positive, somewhere if I take b here, f of b is negative. In between these two, how many solutions do we have, friends? How many solutions do we have? 1, 2, 3. That means odd number of, if you are going to select two numbers a and b such that f of a and f of b are going to have opposite signs. Graphical approach is very important here. F of a and f of b are having opposite sign, then there exists at least one real root in between a and b and odd number of real roots between a and b. See, like we have seen here 1. You can't take a and b such that f of a and f of b opposite signs with no root in between them. With no root in you can't take. So at least one root, or even like odd number of real roots. Odd number of real roots I am talking about. Real roots. Yes, we are coming to the theory of equations. The first problem, let's try to understand, friends. If two roots, basic things only from theory of equation, just you have to understand only the basic part. If roots of this particular equation are equal in magnitude, two roots are equal and but opposite in sign, then so let me take like, see, one root alpha, another root minus alpha, third root let be beta. Okay, these are the three roots. Finally, sum of the roots is minus b by a, which is equals to p. So beta is equals to p, friends. As beta is a root of it, we can substitute p there. So p cube minus p into p square, again p cube plus p cube minus r 0. See, is this a problem, friends? Yeah. See, we didn't do anything, friends, just a common sense thing. Next, second question in theory of equations. Alpha, beta, gamma are the roots of this particular equation, then a cube plus b, alpha cube plus b. Friends, if they are roots, what is sum of the roots that we have? Alpha plus beta plus gamma we have minus b by a, but here coefficient of x square is 0. Friends, again our basic algebraic identity, algebraic identities. When a plus b plus c is equals to 0, a cube plus b cube plus c cube. When a plus b plus c is equals to 0, a cube plus b cube plus c cube is equals to 3abc. Yeah, and as usual, like a plus a, we already know a plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So if this is 0, a square plus b square plus c square will be minus 2 of ab plus bc. Now I am going to substitute everything here, friends, everything here. So a cube plus b cube plus c cube is nothing but 3abc, 3 times of alpha, beta, gamma whole divided by, this becomes minus 2 of alpha, beta plus beta, gamma plus gamma, alpha. What is product of the three roots? Minus b minus 2 of sum of the product of the roots taken 2 at a time, that is plus a. So minus gets cancelled, that becomes 3b by 2a. So very simple things, friends, from theory of equations, just only analyzing the equation, that's it. Okay, third one, Let a and b be two distinct roots of the equation x cube plus 3x square. Then which equation which has ab as its root? We are talking about equation ab as its root. ab as its root. Okay, let's see. Understand the approach. Let a and b be two distinct. Let the third root be c, friends. Okay. Let the third root of this equation, as this is a cubic equation, let the third root be c. Okay. Okay. What is product of the zeros? A into b into c is equals to 1 plus 1. Yeah. From there you get c is equals to 1 by ab. Have you understood? But here c is the root of this equation. You can substitute there. So that becomes 1 by ab whole cube plus 3 by ab whole square minus 1 equals to 0. Friends, LCM 1 plus 3 times of ab minus ab whole cube is equals to 0. Multiplying with negative sign, then we get ab whole cube minus 3ab minus 1 equals to 0. Friends, we need a cubic equation with root ab. So just replace in place of ab x cube minus 3x minus 1 equals to 0. For this equation, ab is going to be the root, because this is what the equation which is going to satisfy now. So hence this is our required thing. If you have understood this thing, friends, like see basic things, the questions are being asked from basic things sometimes, nah? Next, the last topic in today's session is going to be transformation of roots. It is again a very simple, no need to remember anything. I'll tell you a beautiful, easiest approach. I'll tell you. Transformation of roots. In the name itself, it is very clear how the roots are going to be transformed with respect to the given thing. Okay. The thing is like, see friends, they'll be giving you some y is equals to f of x. That means y is equals to ax square plus bx plus c, or even cubic equation, or even quadratic, any equation of 1 degree. Any equation of 1 degree. Now, if they give you such things that f of x is going to have so and so roots. Let's try to understand for either quadratic or cubic. First, let's go with quadratic. Imagine that f of x has two roots, alpha comma beta. Imagine, friends, it's not only for quadratic or cubic. No, it can be for any nth degree equation. So y equals to f of x we are considering quadratic equation. Clear? Just imagine, I take y is equals to ax, not y. Let's not take y. One sec. An equation has ax, like a quadratic equation, ax square plus bx plus c is equals to 0, having roots alpha comma beta. Now, if these two roots are going to be undergone same operation, that means either both roots are being divided by something, or multiplied by something, or being reciprocal, or being squared, or being raised to a power n, both roots should go with same operation. You understand what I am trying to say? Like if both roots are being reciprocal, one root is getting 1 by alpha, other root 1 by beta. Both roots are multiplied by 2 alpha 2 beta, 3 alpha 3 beta, alpha by 2 beta by 2, alpha power n beta power n. In all those such cases, we are going to apply transformation of roots. How? Very simple, friends. See, now I need a particular thing like when roots are like alpha square, we know alpha comma beta are the roots of this equation. Get a quadratic equation having roots alpha square beta square. Very simple. Friends, we know what we are going to do. We just take y is equals to 1 among the root alpha square. Then we express y alpha, everything in terms of alpha is equals to. So alpha in terms of y, alpha is equals to root y we get. Yes, just to substitute as alpha is the one root of this equation. So ax square, that means ay plus b root y plus c is equals to 0. That means ay plus c is equals to minus b root y, squaring on both sides, a square y square plus c square plus 2acy is equals to b square y. Friends, a square y square plus y of 2ac minus b square of y, plus c square is going to be equals to 0. At last, replace y as x, that's it. So a square x square plus x times 2ac minus b square plus c square is equals to 0. This is a quadratic equation having roots alpha square and beta square. Very simple, friends, very simple. Whatever they ask, you have to express like y equals to that, and now you express everything in terms of alpha. Alpha is equals to in terms of y. Clear? And just substituting in the equation as alpha being one root of that particular equation, we can just substitute there. So this is what the simple concept involved in transformation of roots. See, look at this particular question. Alpha, beta, gamma are the roots of the cubic equation. Then we have to find the value of 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta. Friends, here again the roots have been like all the three roots have gone with same operation. Nah? Alpha being added by 1 in the numerator, like 1 being subtracted from alpha. So I take just y is equals to 1 plus alpha by 1 minus alpha. Is that clear? Is that clear? Now express y minus y alpha is equals to 1 plus alpha. From there you get y minus 1 is equals to alpha of y plus 1, which implies alpha is equals to y minus 1 by y plus 1. Now substitute everything there in the question. Alpha is a root of this, na? So y minus 1 by y plus 1 whole cube minus of y minus 1 by y plus 1 minus 1 equals to 0. Friends, simplify this. Y minus 1 whole cube plus minus y minus 1 times y plus 1 whole square minus of y plus 1 whole cube is going to be 0. This is the cubic equation that we got. Cubic equation, we got it, friends. Now for this cubic equation, what are the roots? The roots are 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta, 1 plus gamma by 1 minus gamma. If you wish to simplify and get minus b by a, no issues. But without this also, what is this sum of the roots? Sum of the roots is equals to minus of coefficient of y square divided by coefficient of y cube. From this equation, identify the coefficient of y. See, coefficient of y cube means like here you will be having y cube. Y cube, a minus b whole cube mein y cube hai, like y cube, the coefficient is going to be 1 minus again here also y cube, 1 minus 1 0, here again minus 1. So finally the coefficient of y cube. In that way you can get it easily. Yes. Next, coming to y square, y minus 1 whole square, like y minus 1 whole square, y cube plus y cube minus 1 cube minus 3y of y minus 1. So the coefficient of y square is going to be minus 3. Coefficient of here minus 3. In that way, friends, in that way, if you just substitute everything here, you will be getting the required thing, my dears. Okay, just minus of coefficient of y square. In that way we will get it. Or like if you are not feeling comfortable to take it as a common, then what can we do? We just simplify it. Then directly from there, after simplifying the result, minus of coefficient of y square divided by coefficient of y cube. Last topic in today's session, we are going to go with drawing polynomials. Every JEE aspirant, every student who are going to prepare for JEE has to have this graphing, like able to draw the polynomials. able to sketch the polynomials graphically. Very important, that analyze. So now we are going to discuss how do we draw any polynomial, because there are some particular problems which are being asked in advanced and even mains too, where even only by using graphical approach we are going to get it. No other approach, because no other approach we will be getting the solution. Graphical approach is very important. Please make sure you understand it. Clear? Drawing polynomials. There are very simple techniques that we do in drawing drawing a particular polynomial. If you know them, friends, that's it. Okay. Now we'll see this. Just try to understand. Drawing the polynomials. First, there are some steps. The first step is find the critical points. Find critical points. What are critical points? Critical points means they'll be giving you y is equals to f of x, no? So all the points like dy by dx is equals to 0. Imagine that you are like, if you are equating dy by dx is equals to 0, you got some x1 comma x2 comma x3. Imagine, plot all these points on the coordinate axis. Plot all the critical points on coordinate axis. C axis. Okay. Number 2, find y at extremes. As find y at x tends to infinity and x tends to negative infinity. Extremes, so that we'll be understanding, like as x tends to infinity, y also tends to infinity, means we'll be starting from top notch. As x tends to in that way, like as x tends to infinity, and so this regarding extremes. Now last point, only 3 steps, friends. Join the extreme points. Join the extreme points and critical points. That's it. These critical points are nothing but turning points. You have to join them such that the curve changes the path, curve changes its curvature at that particular. Only 3 points. Drawing the polynomial, very important. Drawing the polynomial. Number 1, find critical points, plot them on the number line, plot them on the coordinate axis. Number 2, find the nature of y at x tends to infinity and extremes. Join the extreme points and critical points. That's it. Okay, we'll do one question, friends. Draw this particular polynomial. Draw y is equals to x power 4 minus 4x whole divided by 4. First, what is the thing? We have to find dy by dx. Dy by dx is equals to, for x power 4 it is 4x cube minus 4 whole divided by 4 is going to be, we'll be fine first. Okay, to get critical points, what do? We equate dy by dx to 0, which implies 4x cube minus 4 equals to 0, which implies x cube minus 1 equals to 0. X cube minus 1 is equals to 0. We got only x is equals to 1 as the real root. Acha? Yes. Now if x is equals to 1, what will be y? X is 1. What will be y? 1 minus 4. 1 minus 4. 1 minus 4. Negative 3 by 4. So here our critical point is 1 comma minus 3 by 4. Next, nature of curve at extremes. As x tends to infinity, friends, as even power, we have even power, y also tends to infinity only. As x tends to negative infinity, y also tends to positive infinity. Y tends to positive, because even power, na, highest power is even, then only that happens. Okay, chalo, let's see this. See, I just do understand the graph. Very important, very easy to. First, plot the critical point on the number line, where we have this number line point 1 comma minus 3 by 4, 1 comma negative 3 by 4. So somewhere it will be here. 1 comma, this point is 1 comma negative 3 by 4. So like as x tends to infinity, as x tends to negative infinity, y tends to infinity. That means y starts from here. Y starts from this part. Okay. As x tends to positive infinity, y also tends to positive. So it tends, like y will be from positive infinity to positive infinity only. So, and one more thing, like in between we have origin, no? Just try to check whether, like if x is 0, y is also going to be 0. So luckily we got another point too. What you will be doing is just plot them in such a way that see, this is the graph of y is equals to x cube minus 4x, sorry, x power 4 minus 4x divided by 4. As this origin is also, this curve is also passing through origin, see. And one more thing, from graph we can easily analyze that this particular is having two real roots. Yes, two real roots. Very important. See, easy to first get the critical points, plot them on the number line. Next, find the nature of curve at extremes. Next, join the extremes to critical points. That's it. Clear? Bas. Next, we'll go with last one. Acha. Another polynomial. Drawing another polynomial. Y is equals to x power 4 minus 2x square plus 5. First find dy by dx, friends. 4x cube minus 4x. That's it. Equate that x cube minus x to 0. X of x square minus 1. That means x you get 0 minus 1 plus 1. Corresponding y you get, if x is 0, y 5. If x is minus 1, 1 minus 2 plus 5. 5 plus 1, 6 minus 2, 4. If x is 1, again 4 only. So what are the critical points that we have? 0, 5, minus 1, 4, and 1, 4. Plot these points on the number line. Friends, very important. Plot these points on the number line. Plot these points. First 0, 5. 0, 5 will be somewhere here. Next 1, 4. 1, 4. Okay, 1, 4. Next 1, negative 4. Minus 1, 4. I mean, sorry. Minus 1, 4. This is minus 1, 4. After getting this, what we are supposed to do? Friends? What we are supposed to do? Find the nature of the curve at extremes. See, as x raised to the even power. So as x tends to infinity, y also tends to infinity. As x tends to negative infinity, y again tends to positive infinity only. So that means the curve is going to be like starting from highest ending to highest, like so. See, sorry, 1 sec, sorry. Starting from highest. Oh God. Starting from highest. See, this is how the graph of the polynomial x power 4 minus 2x square plus 5 is equals to. Okay. This equation has no real roots in practical. If I say how many number of roots for this equation, no real roots. Okay. No real roots. See, okay, we found it, sextants to all these things we done. But how, like in advance, one particular question was asked. See friends, very beautiful concept, and that is they have given the question like this: x power 4 minus 2x square plus 5 is equals to k has 4 solutions. They are asking 4 solutions. This equation has 4 solutions, it seems. This equation has 4 solutions. Then the value of k they are asking. Then k belongs to value of k. Then value of k equals to how much? k equals to how much? See, for all these things, what we do, friends, we just like x power 4 minus 2x square plus 5. We just take y is equals to this and y equals to k as two equations. Like y equals to this one and this one. Now solution means the intersection of these two curves will give us the solutions. Y equals to k is a horizontal line. Just to be practical, friends, y equals to k is a horizontal line. Imagine a horizontal line is sliding throughout the plane. For what value of k, this particular horizontal line will intersect this graph at 4 solutions. Imagine, basic common sense. See, if the line is going to be in this way, that is from above 4 to below 5, for k belongs to open 4 to y equals to open 4 to open 5, the graph, this will be intersecting y equals to k, intersecting the graph at 4 distinct solutions. Clear? See how beautiful it is, how beautiful it is. So the range of k for such that this equation has 4 solutions is k belongs to open 4 comma 5. Are you all clear? Very simple, na? Very simple, friends. Please make sure you understand it properly. See, again, if I say something like this equation, like this has some 2 solutions. If I say just exactly 2 solutions, that means then exactly k equals to 4. At exactly k equals to 4, so k equals to 4, 2 solutions. Okay, k belongs to 4 comma 5, 4 solutions. If I say 3 solution, then that means exactly equals to 5. K equals to 5, 3 solutions. Okay, infinite, like only 2 solutions, like 2 solutions means the graph will be like this. Okay, from 5 to infinity, k belongs to 5 to open 5 to infinity, we get 2 solution. No solution at all, that is from minus infinity to open 4. Minus infinity, no solution, k belongs to like no solution, then k belongs to minus infinity to open 4. See how many number of questions that we have framed just by using this. So friends, that is what to draw any particular polynomial. Basic things that we require is first critical points, plotting them on the coordinate plane. Number 2, identify the nature of the graph at extremes. Number 3, join the extremes with critical points. That's it, friends. That's it. So one question, yes, I am asking you to complete this as homework, friends. Like has 3 like this. Now we have discussed, has 3 real roots. One, first draw the graph of this, and this is in horizontal line, y equals to k. Just try for which value of k it is going to intersect at 1 places. In that way you check karo and get the range of k. Clear? Good. So dear all my dear friends, in today's session we have covered every single concept regarding quadratic equations. From basic to extreme we have covered every single topic, every single concept. And my dear friends, every PYQ till date, every PYQ have been covered. Not only PYQs, even like simple concepts based on understanding levels and all also been covered in today's session. I request everyone to go with the problems which was assigned to you in as homework, and make sure you are going through the entire notes again. See, revising the notes is one of the most important good habit of a JEE aspirant. My dear friends, the next session is going to be trigonometric identities. We'll be having that as a 4th session. So with that, I'm going to conclude this particular session. Before you leave, my dear friends, please do like, share and subscribe our brilliant YouTube channel. One more thing, the most important thing is, please make sure you are following it. You are completely following each and every lecture plan and assigning, and whatever the problems which are being assigned to you, you are making it with your own effort. Any doubts, put it in the comment section. I'll be there to guide you. So with that, I'm ending up the session. See you in the next session. Bye friends. Take care.